So let's go to the page. 531. Example 3. Try this part. And we need to use the cofunction identities to find the sine of the 15 degrees. So actually, sine of the 15 degrees is equal to cosine of the 90 degrees minus the 50 degrees, right? And then this is equal to cosine of the 75 degrees. And we just found the exact value of the cosine of the 75 degrees in one of the previous example, right? And we know this guy is equal to root of 6 minus root of 2 over 4. Let me show you the result for this cosine of the 75 degrees. Here, right? We just found this value in the example 2. And now, after we talk about the identity for the cosine, and let's try to find the identity for the sine of a sum and the difference by using this cofunction identities. So let's begin with the sine of alpha plus beta. Okay. So we know this is equal to cosine of the half pi minus alpha plus beta. And then we just rewrite this as the cosine of the sum of two angles. We have the half pi, actually the difference of two angles, half pi minus alpha, and then minus beta. So now, by the identity for the cosine of a difference, we have the cosine of half pi minus alpha times cosine beta and plus sine of half pi minus alpha times sine beta. And by the cofunction identities, we know cosine half pi minus alpha equal to sine alpha, right? And sine of half pi minus alpha equal to cosine alpha. Then we get identity for the sine of a sum, right? Now, in the similar way, we can find the sine of the alpha minus beta, as we got the cosine of the alpha minus beta. Okay, so this is equal to sine of alpha plus negative beta, and this is equal to sine alpha times cosine of negative beta, and plus cosine alpha times sine of negative beta, right? And let's turn to here. So cosine is even function, so cosine of negative beta is equal to cosine beta. So we have the sine alpha cosine beta, and sine is odd function, so sine of negative beta is equal to sine beta. So you have the minus cosine alpha times sine beta. So by now we have the identities for the sine of a sum and a difference. Okay. Now let's look at the one example. 535, problem 38. And we try to find the exact value of the sine of 5 pi over 12. And we try to split this 5 pi over 12 as the sum of two angles for which we know the exact value of the sine and cosine. Tell me, what are those two angles? Which two angles? Say again. You can split the 5 pi as the 3 pi and 2 pi, right? So now you have the sine of the 3 pi over 12 and plus 2 pi over 12. And after simplification, we know 3 pi over 12 is equal to pi over 4, right? And 2 pi over 12 is equal to pi over 6. And these are the two most common angles, right? So now we get the sine of the pi over 4 and plus pi over 6. Then we can use the sine of a sum to find the exact value. So you have the sine of alpha times cosine beta. So alpha here is the pi over 4, sine of the pi over 4 times cosine of the pi over 6, right? And then plus cosine alpha, that is cosine of pi over 4, and times sine beta, sine of pi over 6. And sine of the pi over 4, root of 2 over 2. Cosine of the pi over 6, root of 3 over 2, right? And cosine of the pi over 4, root of 2 over 2, and sine of the pi over 6, 1/2. And then you simplify, you get the root of 2 times root of 3, you have the root of 6, root of 2 times 1, root of 2, and then over 4. Then done.